Thank you, Anthony, and thank you all for waking up. I know it's early, and I know it's the last day, so put your hands up, everyone. Yay! Thank you. Thank you all, and thanks, Celine, for a great WIST. So I'm really excited to tell you about this work today, in which we've been looking at how to manage ambiguity with a mixed initiative interface. And this is joint work with Tong and Eytan Adar from the University of Michigan, Leo Liu from Adobe, and Karahalios from the University of Illinois. So let's face it, data analysis is hard. You have to learn how to visualize and transform data, and there are a number of tools out there like Microsoft Excel and Tableau that can help with this, or at least help with visualizing the data, but often the data is not quite in the right form, and you have to learn how to transform and aggregate it. One way to make this data analysis process easier is to use natural language interfaces. And in fact, there are a number of commercial tools already available out there. Microsoft has a tool called Power BI, and IBM has Watson Analytics, and that's exactly what they try to do. And they take a very similar approach. They take a user query, in this case, show me medals for hockey and skating by country, and they try to match it to queries that they know how to process and how to turn into visualizations. And if we look at the results here for IBM Watson, you see things that are not exactly what I asked for. So the most relevant question that maps to mine is, what are the values of bronze medals by country for the sport hockey? Or maybe it's for gold medals or silver medals or total medals. There's kind of strange differences in questions, like some of them are what, others are how, and so it's hard for me to exactly figure out which one of these I should click on, but really all I can do is click on one of these and then get to the visualization where I can start refining it and making it closer to what I'm looking for, hopefully thereby answering my question. On the research side, there's been a lot of great work. This is the Articulate system, which is the most recent approach to try and take natural language questions and turn them directly into visualizations. And the database community has also now, for 2 decades actually, been trying to take natural language questions and turning them into database queries. And what's common across these approaches is that the process is fully automatic. They start from natural language and go directly to that visualization. And we believe that as more and more users are starting to use data to make decisions, the variety of questions they'll be asking is only going to grow. And these fully automatic approaches are just not going to be able to handle the large variety of questions that are going to be thrown at them. So our approach is really to expose the inherent ambiguity that is present in these user questions and then let the user correct the system mistakes. So rather than just allowing the user to reformulate their question or manipulate the visualization itself to get to the right answer, what if we could actually let the user affect the system decisions along the way that generate the visualization? And here in this application, this really means trying to generate a better, more accurate database query. But in other applications that use inference, this could mean letting the user affect other system decisions along the way. So let's see how our prototype system, DataTone, works. Oh. All right. So on the left here, you see I've picked my data set. This is an Olympic athlete data set. And here's a little bit of a data overview of this data set. You have a number of athletes, their age, their country, the year that they participated in the Olympics, the sport that they do, and the medals that they won. And a very simple query might look something like this. Show me medals for hockey and skating by country. And again, this seems pretty simple, yet there's a number of ambiguities here. First of all, am I interested in all medals or in gold, silver, or bronze? It turns out there are actually 2 different kinds of hockey because this data set has summer and winter Olympics. So it could be field hockey or ice hockey. And then skating, again, there are 3 different kinds of skating. And so in the system like Watson Analytics, it'll just guess for you and let you pick one that is what it thinks is the best thing. Or in a system like Siri, which many of you have on your phone, it will ask you, did you mean gold medals? Did you mean all medals? And what DataTone does instead is it presents all of these points of ambiguity and lets you decide and explore which one is best for you. So here, I really want silver medals in ice hockey and figure skating. And so I get this visualization. And beyond, of course, the data ambiguity, there are also actually presentation questions that the user might have. So, for example, should we aggregate the data by country? Like, that's one way we could visualize this data, and in which case a simple bar chart makes sense, and of course that could be colored or not. But if I want to see a breakout by these two different sports, then I might want this type of group bar chart, or perhaps a stacked bar chart. And you might be surprised that there's so many more ice hockey medals, and it's because this data set is per athlete, and they're just more hockey players than they are figure skaters. So these are design decisions that in our framework fit in that same representations of ambiguity. So the user can resolve both can set their preferences for the kind of data they're looking at, but also for the presentation of the data. We can also, of course, DataTone allows the user to do direct manipulation for filtering. So I'm going to go ahead and select these 3 countries and then say over time. And now for all subsequent queries, it will keep track of the fact that I'm interested in silver medals in ice hockey. So when I say medals, it's always going to default to silver medals. And when I say hockey, it's always going to default to ice hockey. Keep in mind that DataTone is actually generating a large, perhaps thousands of potential visualizations, and is allowing me to quickly navigate the space of possible visualization through these widgets that we call ambiguity widgets, which let you navigate this space of possibilities. So to summarize, the key DataTone features are we offer a natural language interface, ambiguity widgets for navigating this space. DataTone preserves preferences and enables this exploration of potentially related data. So how do we actually turn questions into visualizations? Well, DataTone takes the user question, generates a set of possible data specifications and corresponding visual specifications, and then ranks them and presents the user the best one. And the user can then affect these preferences, these system decisions, through these ambiguity widgets. So let's go through an actual example. So given a user question, the first step is to parse that question and tokenize it and match it against elements in the database. So in this case, we find that medals and country match exactly or approximately 2 columns in the database, and hockey and skating match against actual values in the data itself, again, in this case, approximately. And this tagging, this classification, is not really sufficient for us to generate a SQL query. And so the other thing we do is we use the NLP Stanford parser, the Stanford NLP parser, to actually generate a dependency tree. And so in combination, so we combine using this tagged question along with the dependency tree to generate a set of possible data specifications, each of which corresponds to an actual SQL query. And to give you an example, one data specification might say gold medals for ice hockey and figure skating. Another one might say silver medals for ice hockey and speed skating, and then yet another might be about total medals. And for each of these DSPs, we then generate one or more visual specifications. And so for this actually fairly simple query, we end up generating 576 data specifications, up to 10 visual specifications, and which result in over 5,000 possible visualizations. And of course, your next obvious thing you're thinking in your head right now is, well, that's a lot of visualizations, Mira. How do you decide which one to show me? And the simplest, shortest answer is we use a lot of heuristics. And the heuristics are both data-oriented and visualization-oriented. They look at what's actually in the data in order to rank certain data specifications higher than others. And similarly, we use previous work on what are most appropriate visualizations given certain types of data to influence which visualization specifications actually make sense. But we have a nice description of the ambiguity space in the paper, when we break out all these different sources of ambiguity and how we address each one, I really encourage you to look at the paper for more detail and really dive into the details. So to evaluate DataTone, we compared it against IBM's Watson Analytics. And you're probably thinking, boy, these are really different interfaces. Why are you doing this? They're really apples and oranges, and you're right, they're really different. But what's nice about them is that there are these different points in the design space. One, gives you accurate visualizations, or one is, trying to guess what you're trying to say, and the other one is doing its best to interpret, but then letting you fix mistakes interactively. And we really felt that this could give us nice feedback about the general approaches of these two systems. And to evaluate, the actual evaluation methodology was something we termed Jeopardy-style evaluation, which asks users to read a fact and then create a visualization that proves or disproves that fact. In our case, we were giving them all valid facts and asking them to create visualizations that illustrate those facts. And so here is one such fact. China didn't win any gold medals in speed skating, but it won the same number of gold medals as the United States in figure skating. And the reason we chose this style of evaluation is in our early tests, we would give people questions or goals the way you normally do in these types of evaluations. And what we found was that people would just take the question and just put it right into the search box. And so we weren't seeing any variety at all in the kinds of questions people were asking. And they weren't really using their own terminology, their own language in trying to explore the data. And so we felt this way we kind of pushed them to actually use their own brains. So the study itself was about an hour. We had 16 participants, 3 data sets. We gave 10 facts per data set, and no one was actually able to complete all the facts, so that was good. And we told them, do as many as you can, and we collected both quantitative and qualitative data. And the results were quite optimistic. For us, 14 of our participants preferred DataTone. We saw that folks attempted more facts with DataTone and completed more facts correctly. But of course, Watson Analytics is a commercial product, and so people felt like it was a more polished interface. They really liked how it looked. They liked the rich visualization modification interface and elements. Just to give you some quotes, one participant said it was easier to fix errors. So really this focus on fixing system errors came through. And then another user said, I wasn't worried about being accurate. And that's really one key difference here. Watson takes the user's language and maps it into its own language, and sometimes pushes the user to think about this other language that it is using. And in DataTone, we're really trying to just take what the user gives us and interpret that as best as we can, and then hopefully allow them to fix it appropriately. So there are of course, a number of limitations to this system. There's a lot to do, so this is our first step in this direction. First, as I mentioned, ambiguity resolution really relies on heuristics, and we'd really like to take a look at having a more general probabilistic framework for resolving the ambiguity, one that is, becomes specific to users over time. We've also I've shown you these very simple list type ambiguity widgets, but there's a lot more we could do there. We could look at sliders, we could look at checkboxes, and look at whether the ambiguity widgets themselves can reflect the source of the ambiguity or the kind of ambiguity that is present in the system. We also are just looking at one table, so we're not doing any integration across data sets. And then I forgot to tell you that you can talk to it. You can talk to our system, but we haven't really explored the whole speaking side. And in fact, I think that really it's on the mobile platform where speech is going to be most critical. And if you're going to have a speech interface, then there's a very different type of state management that you need to do, because in the desktop, you can just always refine your query by typing, and that's, of course, harder to do on a mobile device. So in conclusions, I hope I've convinced you that natural language interfaces can really lower the barriers for these types of complex applications, and that a mixed initiative approach allows the system to fail, but still fail gracefully by letting the user interactively fix some of these mistakes. And by modeling and surfacing this ambiguity, we not only allow for correction, but we also enable exploration of this data set. And so with that, thank you so much for waking up this early. I really appreciate it, and I'll take your questions.
Okay, we have questions lining up.
Hi, Mike Terry, University of Waterloo. Really neat stuff. So do you have a sense for how often they need to use the ambiguity resolution? Is it like for every query they need to use it?
It's a great question. I would say that in our studies, yes, although once they've kind of dialed in to the actual, so part of it is understanding your own data and knowing what's in the data, right? So in our study, they didn't know really the data set, and so they would just go. So, the other piece of it is that you can imagine using your own language as a shorthand, right? So you don't have to type out a whole value, you can just say something short, and then once you've created that relationship, then going forward, you just use that short form. I mean, you're not at that point actually using the ambiguity widgets, you're just using them once. But I do think that for almost every user, they will be important at some point, but maybe not in every single query.
Yeah, so I guess my question was, the follow-up was, is the problem really then getting them to the best set of ambiguity widgets as fast as possible, rather than trying to come up with the best interpretation of the natural language input, right? So you could have like a staccato kind, or like you were saying, a much more abbreviated query where you're like, metals, silver, hockey, bar chart, or trend line, right? Where you're giving these keywords to go and zero in on the most likely ambiguity widgets as fast as possible.
So I think, yes and no, right? It kind of depends on your task. If you're working with the exact kind of piece of the data, then yes, like once you've narrowed in, then you don't have to worry too much about presenting more different interface elements, and you can kind of hide them to the side. And in fact, that's an ongoing question of like, once you have kind of gone down one path and you have all this state, where do you put all the UI that shows you where that state is? But there is this thing about data exploration that's about actually looking at related parts of the data set. And there's open, interesting questions about how to do that. Well, one of the previous works, this articulate system, actually suggests possible visualizations you could look at next. You could also imagine presenting actual data pieces that are also relevant. You should also look at, silver metals if you're thinking about gold metals. That's a very simple one. But so, and in that case, I guess you could have the system present the data the right way, and so you wouldn't have this ambiguity. But it's a good question. It'd be worth exploring definitely further. Yep.
Michael Mayer from EPFL. So this is a great work. Thank you. I like the fact that you present the result at the same time as you present the ambiguity. One of the related work, Popescu was my teacher, and I would ask a question, maybe you would ask, do you plan on disambiguating the parsing tree of the query?
So, it's a good question. So part of what we're hoping to do is, so there's maybe yes, maybe no, right? Part of the goal is to present the user with something that makes sense to them, and the parse trees are often really hard to interpret. And so, would we actually show the parse trees and have them pick from them? I don't think so, but there may be elements of it that could be really useful in the disambiguation. And so, for example, using conjunctions and showing that these things are together versus separate. And the longer the queries are actually, the more important this becomes. And so I actually see it as something to really consider going forward. But we haven't explored it in detail, just mostly because it's hard to think about how to actually present this information to the user.